In this event, we'll be exploring hypermedia and the hidden powers of utilizing hypermedia within web APIs. But first, what exactly do we mean when we discussed hypermedia? Well, in its fundamental form, hypermedia involves interactive content. The World Wide Web, for example, is a great example of hypermedia in action, as users have the ability to link to and navigate to pages. In the context of web APIs, hypermedia as the engine of application state is one of the core constraints of REST, the guiding light for API design outlined by Roy Fielding in his pivotal 2001 dissertation. Though ironically, this constraint is not often applied in many RESTful APIs on the market. So what does hypermedia enable? Well, hypermedia can enable API clients to explore and understand resources at runtime. This can allow clients to identify accessible data and functionality as they progress through an API, taking further action based on the response it gets. But there's a lot more to it than that. Hypermedia APIs offer unique ways to control data, link to pertinent information, and orchestrate advanced security mechanisms as well. So in this livecast, we'll be exploring hypermedia a bit deeper to discover how to utilize it in innovative ways. And I'm excited because today we're featuring two great hypermedia API experts. We have Tomasz Pluskiewicz and Michał Trojanowski. And so Tomasz will be starting out by introducing a few different approaches where everything about an API becomes a resource in its own right. So I'm interested in hearing that. And then we'll be hearing a topic on how to implement an authentication flow entirely driven by hypermedia by Michał. So today we'll be doing back-to-back talks followed by a Q&A session. So if you are watching live, just type in your questions as they come up and we'll try to get to everything at the end. So first up, let's bring in Tomasz. And feel free to share your slides whenever you're ready. Thanks for being on the call today.
Hey everyone! Thank you, Bill, for having me. It's a great pleasure. Without further ado, let me just get on with it because I have a bunch of slides and a lot of content to show you in just about 20 minutes. You may be wondering about the title. Your API is your API, and that is a reference to a tweet by Mike Amundsen from a few years ago, where Mike said that data model and object model and resource model and message model are not the same models when building web APIs. And I used to treat this as unquestionable truth. Well, Mike goes in a follow-up tweet saying that they need to be able to independently be implemented independently so that they don't break other models. And recently I've actually started thinking that maybe I should be questioning this assumption, and I'm about to show you on a few examples why I think otherwise today. So to understand APIs a little bit, I would like to first quickly show you a bit of history where APIs came from. So the farthest in history that we can go is, in fact, before internet, even before real networks. For example, this is 1964 diagram from Paul Barron. So Paul Barron was a researcher, and this particular diagram comes from work he did for US military, designing a network which should withstand a nuclear war. So at the height of the Cold War, as you see, on one end of the spectrum, it would have a centralized network. And obviously, if you destroy the central node in such a network, the entire network is automatically disabled. So the only consequence is that a network that is able to withstand damage would be a distributed network. And this went on, this proposal and similar proposals went on to be a foundation for ARPANET. And unsurprisingly, the internet that we know today is also a distributed network built in a similar fashion. Then, of course, the other milestone for APIs is the mentioned already dissertation by Fielding. And while preparing for this talk, I actually found this quite insightful article linked below by Sinclair Target. And I come to agree with the statement that the dissertation itself is not really about APIs. So we are focusing on chapter 5, which brings the details of the hypermedia constraints and the other constraints for RESTful architecture. But in fact, the dissertation itself is about the protocol itself and how to build networks distributed hypermedia with HTTP protocol, but not necessarily APIs. It's really hard to find details on API design per se. And Fielding himself goes in to describe the representational state transfer intended to evoke an image of how a well-designed web application behaves, a web of pages where users choose links to progress between representations of resources, those representations being transferred to the user and rendered for their use. And that's how I think of APIs, which is in fact closer to an earlier work by none other than Tim Berners-Lee in his 1989 CERN information management proposal. He proposed a network of documents, but meaningfully connected. This went on to become what we know of the internet today, but the internet as we know it is basically just HTTP documents transferred over HTTP protocol, but they are intended for human consumption. So we have text, now we have different kinds of media embedded in the documents, but in the end, it's for us to read in a browser. Tim Berners-Lee already back then proposed that the documents or the resources on the web are actually connected through meaningful links so that machine agents, not only humans, would be able to understand the nature of those links and follow the resources, follow those links to get to other resources. So this is what Bill already mentioned, and what I said, that everything in fact is a resource, and that itself is not really groundbreaking. That's nothing new, and also not clearly theoretical either. Not sure if you would be familiar with linked data. For example, linked open data cloud. That's an ongoing project which combines, builds the graph that you see on the right, and combines data sets with resources connected through links. So as of last year, it was already over 1,300 data sets connected through Hypermedia. Again, Tim Berners-Lee actually provides this 5-star linked data evaluation scheme for good linked data on the web, which should be in an open license, in a machine readable format, even better if it's non-proprietary. For example, CSV is better than Excel. And ideally, it would be RDF document linked to other documents. And the linking is quite important for example, for the cloud that I showed you right there. There's a requirement for certain level of quality. So there has to be enough links to other resources for a new data set to be included in the cloud. Also, then what are APIs? And like I said, everything is a resource, and an API is nothing else but a graph, a network of resources connected through unambiguous, meaningful links. So over the next few slides, I will show you examples of resources taken from my ongoing project right now. And all of them will be RDF in JSON-LD format, JSON-LD being maybe not my favorite, but probably easiest to understand for the less initiated. So first off, we have data as a resource. So obviously, the actual subject of any given API and data set will be resources. So here we have a bus registration. So my project is a database, an API of Polish bus market. So a resource has an identifier, which has a URI. It has a link to its type. So the type is also a resource. It's not just string. It's also a resource which represents a registration. It obviously has links to other resources. It uses all properties which are effectively URIs. So they are unambiguous. Anyone who comes across this resource can potentially look up this on the web and also find out more about that property. And finally, resources would use terminology from well-known shared vocabularies. For example, SCOS is a taxonomy vocabulary, and schema, number of axles, you see right there, schema.org, many of you should be familiar with, is a Google-driven vocabulary to describe different information on the web, and it helps Google also to meaningfully index pages which they crawl. So I said that the class is also a resource. Now, on the left, you see the owner, an instance of the owner linked from the registration before, and an owner class. So again, it has a URI as the identifier, again, uses shared vocabulary for its description. And it also links to a super type, which is, again, in the shared vocabulary schema organization, which means that any consumer of an owner resource can, by following those links, figure out that instance of an owner. So every instance of the owner class will also be an organization class, and that's already built into the representations and the graph. A second example of a class is the registration that I mentioned before. Now, this one is slightly different, and in addition to being a class, it is also a shape, which is a term from Shackle Shapes Constraint Language that is W3C standard vocabulary, which is describing graph data structures, obviously RDF graphs. So predominantly, it would be used for validating correctness of resources. So for example, what we see here is that a registration will have two properties, the preferred label, and at most one, and exactly one number, which will have to be an integer. But Shackle has many other uses. For example, with additional information, additional metadata, it can be used to, already like this, can be used to build forms for entering data, or even to build actual interactive user interfaces. And it can be easily extended with additional properties without interfering with the other terms. And it doesn't stop there. So the API itself can also be described using RDF and becoming a resource. So for that, you can look up Hydra Community Group. Hydra is a vocabulary for describing APIs with RDF. It's actually linked, unlike most of the data stuff I'm showing, it's actually linked to your data through an HTTP link header. And among other things, it will instruct clients on what the API constitutes of. For example, for this API, it would have a supported registration class, and that registration class supporting a request, an operation to update using the put HTTP method. Obviously, the payload for that request would be an instance of registration. And what's more, but that's a slightly custom thing here, but I use code exactly like this for actually linking not only to other resources, but even to implementation. So this is for now only used in the backend, so that I actually hook up already also the handling code for my Express app. But this method could easily be also used to directly link to web JavaScript in a code on demand constraint. Last example for the snippets is access control. There's already a vocabulary for describing basic access control. So it is something shared with a stable base URL, actually started by Tim Berners-Lee yet again, and now it's part of his solid project. It's quite simple. For example, this authorization resource gives a group of data owners. Again, of course, the data owners group is also its own resource. It would grant them right access to all instances of registration. So with a bit of additional terms similar to these, it provides fine-grained control of what the agents can or cannot do with resources. And so just a food for thought, I'm thinking now that maybe we can rethink the software as a service term label. And I don't know if you like those terms, software as a resource or maybe resource as a service, because essentially that's all it is. It's just resources on a web. Here, the resources I just showed you right there are those snippets, all connected through their respective links. So starting here with the registration instance, its type, the operation, the right registration of authorization resource, and as well stuff that I haven't actually showed you. So the data owners having a member, so a person who would have created the registration resource. So that's also expressed using a standardized vocabulary called activity streams, which can be used for anything that is representing events, like the create event. And because everything is a resource on the web, you would essentially build the application pretty much going back and forth to the API. First, for example, it would get the registration resource, then might get the API documentation resource and hand over the representation of the registration to a view rendering component. The view rendering component doesn't have any assumptions, so it gets the shackle shape similar to the one I showed you before and returns back HTML view for rendering. And then sometime later, through user's action, a form might be rendered based on the put operation, which again, having no assumptions about what the resource is and what the request is going to be. It will then again fetch, this time from cache, because those are easily cacheable web resources, fetch again the shackle shape, return the form, and having submitted the put request as prescribed by the operation resource, we get back a modified presentation and circle back to actually rendering an updated view. So in case you're still asking yourselves why, I figure that this pattern brings a number of measurable benefits. So first of all, discoverability. Like I said, clients do not have much hard-coded. They're not hard-coded against a specific API, and thus they discover the capabilities and the contents of resources as they go. But similarly, it can be also done for purely explorative purposes. So starting from any particular resource, one can follow the links to try to figure out the big picture of a given API and data set. And because there's no assumption being made about resources up front, they can easily evolve. So anytime the hypermedia changes, the API documentation changes, the class, those shapes change, this would be automatically reflected in the consuming code. So it only needs to be hard-coded against the vocabularies, but not the actual API's data. And this makes APIs easily, or the resources long-lived. applications can come and go, or there can be multiple applications consuming same resources more easily. And that's nicely summed up by the data-centric manifesto, which I invite you to have a look at. That with self-describing data, applications do not have to hard code interpretation and meaning of the data. So to sum up, I think that everything should be a resource within an API, and it has to be connected through links to other resources. Such resources need to use shared vocabularies for unexpected consumers, new client applications to be able to interpret and function with them. And so we cannot hard code API-specific semantics in client code. That's all I had for you. On the last slide, we'll share this later, and of course, this is also being recorded. I give you a bunch of links for everything that I mentioned. So all the blog posts and documents, and also the different kinds of vocabularies that I showed you on the snippets, and the actual resources I showed you, they can be actually executed from working code in my repository.
Okay, awesome. Thank you, Tomasz. Yeah, I agree. Having more like self-described information within the API itself can lend itself to a lot of those benefits you're talking about, and could probably enable some really interesting automations and new programmability as well. I like the whole X as a resource concept, and I think we're going to see some parallels with Michael's presentation on access as a resource. I'm hoping there's some similarities there. Well, I have a lot of questions after that. Really interesting stuff, but let's keep that for the Q&A. And if anyone is listening in real time, feel free to jot down some questions, and we'll take everything after this next presentation. All right, so take it away whenever you're ready.
Okay, thanks. Let me share the screen and need to find my presentation. Okay, hi everyone. I'm Michał Trojanowski. I'm a product marketing engineer at Curity. For those of you who don't know Curity, we're a company that works on an implementation of an OAuth server. So we're an OpenID Connect provider. And we work with OAuth, OpenID, identity management a lot, and also authentication. So in this presentation, I would like to tell you a bit about using Hypermedia to drive an authentication flow. And when we think about authentication, I think the first thing that comes into mind are passwords. And we use usernames and passwords to authenticate really a lot. Still, I think it's probably the most popular way of authenticating users. And I think one of the reasons for that is that passwords are easy to implement. All you need in your app is to provide a simple HTML form, collect the username, collect the password from the user, send it to the server. The server checks the database, whether it can find that record, and the user is authenticated. And that's really easy for developers to use. But at some point, I think we found out that it's actually not enough, and there are some features which are missing, and we need a bit more. So we started to add, on the one hand, security features, and these are things like multi-factor authentication, right? So now you don't only provide the username and password, but then if that's been verified, then the server sends maybe a text message to your phone or an email, or the user has to use a authenticator app to add another verification, another level of verification of their identity. And on the other hand, we wanted better user experience, and that's where all the federated logins came in. So at some point, we found out that people started to have like myriads of accounts in different services, and they didn't want to remember all the passwords, or they started using just the same password for everything. So we came up with this solution where you can just use your Google account or GitHub account, and my app will just trust Google that, okay, if Google authenticated that user and Google says that this user is really what they claim to be, then I trust that, and I will just authenticate my user. So we started to add those new features to the authentication, but then we started to further evolve the process, and you can notice that I start calling it a process, because at some point authentication stopped being just a simple action where you have to provide some data and send it to the server and verify if it's okay or not. But it started to be a complex flow, a whole process through which the user has to go. And you might have noticed on some pages that when you want to log in, you won't see the classic username and password form, but instead you will first see a username form. You have to enter your username, click next, and then you're presented with your password form. And I've seen people, being a bit surprised. Okay, what's the reason? Why can't I just have, my regular one form and provide username and password and then log in? Why do I need two forms for that? Well, the answer is that because it's not just that simple login that you're doing here. It is a complex flow driven by the authorization server that you go through. And when you give your username and send it to the authorization server, then the authorization server, based on your username, will decide what the next step should be. And very often this can be actually login with password, but in other cases, maybe other users will be authenticating with different methods. For example, they will have to use WebAuthn or something like that. So, and a good example, I think, might be when you have a normal user, regular user, when they try to log in to a website, then the server says, okay, that's a regular user, so password is enough to authenticate them. But if you are an admin and want to log in, then the server checks, okay, that's an admin username, so they should log in with better credentials. So maybe they should log in with their YubiKey, like a physical key for authentication, and not the password. So you see that this authentication became more complex, and it's just more than just sending one information or two informations in case of a two-factor authentication. But authentication types and the authenticators are not the only things that we added to that flows. We started adding things like filters or actions, or you can call them, they're called differently, but things like, for example, the authorization server can check for impossible journeys. So you logged in half an hour ago, and you log in again now, and the authorization server sees that, okay, this login is 2,000 kilometers from the place where you logged in from last time, half an hour ago. And the authorization server might say, okay, this looks a bit suspicious. Well, maybe use the VPN or something, and just the IP changed. So it will ask for another factor. It will ask you to, okay, password is not enough for me now because it looks a bit suspicious. So I want you to use another factor. And or it can be something like checking the office hours. And if you log in during your office hours to your office app or something like that, then password is enough. But if you try to log in after office hours, then the authorization server might say, okay, that's a bit suspicious because normally people shouldn't log in after office hours. So maybe I will send a code to your mobile phone and verify that it's really you and not someone just trying to use your password to log into the server. So you can see that, again, more complex decisions are added to that whole process. And it actually, the authentication became a state machine where the user goes that flow through each step, and the authorization server decides what the next step should be based on the previous input. Sorry. And if you think about it, think about that state machine, and think that usually authentication happens in the browser. We can see that actually Hypermedia it's what drives that authentication, that flow that we currently use. So browsers are like native Hypermedia clients, and the browser doesn't know anything about the authentication steps or how the authentication flow looks like. It just gets responses from the authorization server, and each response will contain the view that the browser should show the user and some actions that the user can perform. So points to the next step in each path that the user can take. So in its current form, we can see that complex authentication flow is actually driven by Hypermedia. But what if we want to turn it into an API? So we want to take the browser out of this equation, and we want to have those two requirements for that API, so it works the same as that authentication flow in the browser. So the first requirement is that we want the authentication to still be that complex flow. Very often when we think about auth and authenticating a user through an API, people think about the resource owner password flow, the ROPC. It's a flow where you can send the username and password directly to the authorization endpoint together with the authorization request. The server can verify the user and authenticate the user and send back the tokens or send back the code, which can be exchanged for tokens. But it's actually going back to square one, because now again we can only use the username and password, and we can't use any of the other features of this complex authentication flow. So we can't have the two-factor authentication. We can't have the authorization server decide what to do with the user and maybe ask for another factor or something like that. So ROPC is not enough in this situation, because we want the API to be able to implement that complex flow. And then the other requirement is that we still want the authorization server to stay in control of that flow. So it is possible for the clients to implement some parts of that flow. So maybe the client can check whether these are office hours or not, and maybe it can ask for another credential. But on one hand, of course, it can have some security problems to have that implemented on the client side. But more important is that whenever we would like to change anything in that flow, then we would have to make changes in the client. It's probably not such a deal with web clients when you have a website or an SPA. But if you think about mobile clients, then when you want to change anything in a mobile client, you have to release a new version of the app, and then somehow ask your users to download the new version, update their apps. And anyone who's working with mobile apps knows probably that it's really complicated and it's really annoying, and people just don't do that. So we don't want to have that in the client, and that's also not that Hypermedia, right? So a Hypermedia Authentication API is an is an implementation of such an API which fulfills those requirements. So in a Hypermedia API, we can have that complex flows because the authorization server controls those flows. It sends the responses back to the client and just tells the client what's the view, what data do I need at this step, and what other actions you can take, right? So if we want a true authentication API, then we need to implement Hypermedia. And I want to show you some examples of Hypermedia responses of the API that we use at Curity in the Curity identity server. So this is obviously JSON responses, and not sure if I can get a pointer here, but okay. So here we have an example of some JSON responses of the API. The server tells the client that it's an authentication step. So the authentication hasn't finished yet. It's just another step in the authentication flow. And it tells it that it's a selector, and more concretely an authenticator selector. So the client knows that, okay, the user will have to select an authentication method out of the list that is provided here. And every item on the list has a href, which is the link to the next step in this Hypermedia flow. And another response, that's a part of a response when the user selects an HTML form. So in the upper part, you can see that it's the description of the form itself. So just the usual things that you would have for an HTML form, like the actions, where you should send the results, the method which you should use, the content type, and so on. And the fields that the server requires, the username and password in this case. But you have also links. So sending the form back is not the only option that the client can undertake, or the user. And there are also other paths that the user can choose if they forgot their password or need to register. There are other endpoints that should be called next in that Hypermedia flow. I'll show you a quick demo of how that works. So I have a mobile app working on iOS. It's just a demo app which consumes that Hypermedia Authentication API. And when I start the authentication, so first I get a response from the authorization server, which shows the list of the authenticators, so I can choose which one do I want to use to authenticate myself and log in into the app. When I choose the standard HTML form, I get another response. Again, this is the same response that I showed you before in JSON format, well, obviously rendered with the links shown here and the HTML form for collecting the username and password. So let's try to log in. And when I log in, then the authentication is finished. The app gets an access token and can now access some APIs. And let's quickly change some settings. And so I have here the admin UI of the Curity identity server, and some settings for my iOS client. So I want to now change that client so that users will only be able to log in using Google and not any other authentication options. So when I update that and get back to the application, I don't even have to restart the app itself. I don't have to make any changes in the code, obviously. And when I start the authentication again, I don't get any list of possible authentications. I'm redirected to a browser because Google needs to be the authentication needs to be done in the browser itself. but I'm already authenticated. When I go back to the app, I get again an access token. So you can see that the client just reacts to the responses from the server and follows the steps that the server tells it to. Doesn't know anything about the flow and doesn't have anything hard coded there. And that's what I wanted to show you. Thanks a lot, and I think we have time for some Q&A. But
awesome.
Giving back to Bill.
Yeah, thank you, Michał. Awesome demo and good overview of how complex authentication has changed over the years. I think end users just don't realize what is happening behind the scenes. People just assume like there's a password and a username, or you're just logging in with Twitter or Facebook or Google or whatever, which I don't do anymore, because then you become intrinsically linked to this social platform to access another platform. I just hate that idea. So I'm glad, others are trying to solve this issue. But yeah, your talk makes me realize like how many possible variables there could be in that whole flow. There's really, and seems like there's an infinite number of like potential combinations of things, which really, lays the basis for the whole hypermedia
that's
concept, I think.
That's true. Well, that's what I wanted to. That was my point, actually. That authentication nowadays is just too complex. You can't simply. Well, you of course can do it through an regular API, but you will lose a lot. And going hypermedia with it is the way, I think, is the best way to do it properly.
I'm interested in, does that help security in general? Because if you're only showing what the client needs to based on the state, could that be, avoid overexposing data? Or is it kind of the opposite?
I'm not sure. No. I would say that it's as secure as in the browser. So in terms of security, I wouldn't say it's better or worse. It's still an API. So when you implement, you have to make sure that you don't expose too much data in the responses. Well,
yeah.
In the authentication process, usually the data which is exposed it's the steps that you ask the user to maybe you ask the user for an input or something like that. There's not much data about the user themselves. Right. So maybe in this case it's not that dangerous, but still it's an API. So
sure.
I think you should still go through the OAuth
proper channels. Right. Bad actors can make inferences, and just being careful. Yeah. All right, let's talk hypermedia formats, because I know Tomasz, you were saying that you don't really like JSON-LD that much. I'm curious to get your take on like the differences between hypermedia formats, and what do you like using out there?
Well, I see. Yeah. Well, I don't really like JSON-LD that much because it's JSON for one. But then I really stopped viewing the formats as being all that important. I mean, unless we're really talking completely different representations of media, such as you might have a resource which is an image, and you could get a JSON representation of that image to maybe get EXIF information extracted, that sort of thing. And then you might content negotiate for an actual, you could decide if you want JPEG or if you want PNG. That would be a meaningful content negotiation. Negotiating between JSON and XML, at least given mostly I work with RDF data, the actual format is merely a vessel for transferring the data, and then RDF is always just the graph. I mean, it's an important part that due to time constraints today, I didn't really mention that much, but all of those resources, they are pretty much uniform across the board, and from the client to the server, and all intermediaries that actually touch the representations, they don't really concern themselves with if it's JSON or if it's not, if it's another format. They always would work with the abstract model.
Right.
So for JSON-LD, first of all, it suffers some of the issues of XML itself, because the JSON-LD is a graph, but it actually has to be crammed into a tree form, which means that you can have the same graph can be represented as different JSON documents. So it makes it really difficult to work with pretending it's just plain JSON. And otherwise, APIs being just JSON, essentially each API becomes its own special snowflake. Everyone invented their own JSON forms, and it's really hard to really correlate the different presentations coming from APIs, because those resources are not unambiguously represented.
I see. And Michał, Everpot was wondering, what format does Curity use for its responses in this Hypermedia
Yeah,
API?
which I must say that last sentence from Tomasz is very much linked to answer of Everpot. Sorry. Yeah, we use actually a proprietary format for the responses. So it's not yet released, I think, but it should be released soon, an SDK with models for the responses, so that it's easier to work with that. But yeah, it's unfortunately it's not interchangeable as in Tomasz's examples there, right?
But I do have follow-up question. I was going to ask a similar question myself. If there is talk within Curity to, I don't know, reach out to your competitors or maybe independent players to standardize that as an interchange form, even if it were just JSON, but ideally I mentioned the events, the activity streams, and many other RDF standards are really hiding the fact that they're RDF, and all of the development and all of the examples are in fact JSON-LD. JSON-LD makes it fairly easy to, what you showed on your slides, just make them unambiguous by just adding a bunch of annotations without really changing the overall structure, so that it can keep the plain JSON clients, but also make it easily reusable across new consumers.
Yeah. It's actually also another another question of the Q&A. Yeah, we created a draft on RFC and wanted to have that API standardized. Not sure at what point is it now, but I know it's been published as a draft, and probably gathering some comments from the community. So we tried to make an open standard, so that is interchangeable between different vendors and different clients.
Are you guys noticing interest from others in the space to help it out?
Not sure about that.
Okay,
yeah.
We'll see.
I haven't heard, so probably, yeah. So probably not much, yeah.
Okay.
For now,
we'll
it's still fairly new, so it might take some time.
Understood. All right, we did receive a question on Twitter, which I think we could tackle. What do you think about hypermedia and strongly typed languages? How can these worlds be combined? Michał, you want to kick things off?
Yeah, well, I have my thoughts. Especially, yeah, if you use unambiguous languages, as Tomasz said, and use like some common schemas or dictionaries, then it's probably easier, because I'm not sure if there are libraries which help you consume those responses, but I'm pretty sure there's probably something is out there, or if not, it's easier to create those. And if you have proprietary formats, then of course it's a bit more difficult for, especially for strongly typed languages, because in JavaScript you just can consume it into any object and a map and read anything. But in Java or Kotlin or C# might be a bit more complicated. But this is one of the reasons why we want to release an SDK for our API, because we know that it might be a problem for developers to work with that. So that's something we want to do as a step in this product, that make developers' lives easier there.
Right. Yeah, any thoughts on that, Tomasz?
Well, like I mentioned on my slides, important part is in fact to rely on the shared semantics, or maybe even if it's something API specific, then you need to be able to extend the shared constructs of the classes and shapes and whatever else I mentioned. But that actually is a bit of a chicken and egg problem, because you gain the benefits of not hard coding against the specifics of your API and of your data, but you need actually to first upfront build a tooling that will be, you aspire to build generic tooling, and that itself, first of all, it's an upfront investment and also a little bit of a limitation. So it's not as easy as it sounds, obviously.
Gotcha. So yeah, hopefully some developer experience libraries or toolkits can help out with that. Kind of moving things along here. I'm curious about Hypermedia and its relationship to other standards out there for representing APIs. I mean, Tomasz, your whole talk was about the API is the API is the API. It can be self-described as a resource too. You can use Hypermedia to make a representation of the web service itself. Would this nullify the need for using OpenAPI specification?
Well, in the long run, I guess it would, but in practice, it's being widely used, and much as
in theory, I guess I'm saying.
Yes. Well, much connecting to the strongly typed language question, OpenAPI could potentially be used in a similar manner. I mean, there's no reason why why a client wouldn't fetch the OpenAPI document dynamically and continue from there. But in practice, it's being used to auto-generate clients, which I despise with my whole heart, because in the end, as soon as the API document changes, the clients are obsolete unless they regenerate. And then if there's additional code built on top of the generated API description, it's just adding to the snowball effect of changes necessary for an update. And then, given not enough time, as it usually happens, vendors are prohibited from really changing the APIs. So that's a big problem. So unless, I know there have been talk in OpenAPI for a more Hypermedia-like or driven approach, but I don't think it's really winning there. So unless that changes, I think OpenAPI is not currently the best candidate for a Hypermedia driven approach.
Right. Yeah, I think you outlined something that a lot of people are feeling, that this whole idea of auto-generating all these clients and SDKs from a single source of truth with the specification. It sounds really great in theory, but then in practice, seems like they're just the generation packages, they need more code added on top, and it just makes things more complicated. Is that kind of your experience?
Yeah. Yes. I mean, depends also on the nature of the generated code. But
Right.
I mean, if you generate the code and then customize it, it also makes it difficult to regenerate because you have to reapply your patches. So on, but then the generated code have to be really, really flexible with extension points for customization. But it all just builds tension. But of course, reusable generic libraries for hypermedia formats, like similar to what I've shown, of course, have their own drawbacks. They need to be built up front, and also they will essentially be a set of limitations of what you can and cannot do. And it's a hard balance because there's actually no winners in such race.
Michał, any thoughts on comparing Hypermedia to other, API representation standards?
Yeah, very similar to Tomasz. I think so. Yeah, and I agree with your point that also build that it looks OpenAPI looks like it should be so good and solve so many problems, but then you can have that situation where somebody writes the specification, then somebody implements it, and then implements the client and implements the API. So you have 3 points where you can do stuff a bit differently or change something, or when you change the specification, then you have the API which has to change and the client which has to change. And if you try to do everything automatically, then there probably something will break. But yeah, with Hypermedia, it's just so much easier, right? It's of course things can break if you add something which wasn't there before, if I may say that. Like comparing to or taking an example of the Curity API. If we added a new type of response, which is not an authentication step, but something else which the client maybe doesn't know and doesn't know what to do with it, then it's a problem. But if it's just another authenticator type or something like that, then if the client is written properly, then it just evolves with the authentication flow.
Yeah, that's interesting. We know that Curity is implementing this Hypermedia Authentication API. It's in production currently, right? It's available to clients as of now. Well, Aparna is wondering about other real-world use cases of implementing Hypermedia-driven APIs, especially using Hydra. Are there any production sites that are consuming these APIs and taking advantage of them by generating dynamic forms? If so, were there any challenges? I feel like we've covered some of this on the Nordic APIs blog, but I just don't have examples on the top of my mind. Do you guys know of any?
Well, not production, maybe not production site, but I know that API platform, which is a framework built on top of Symfony, uses Hydra a lot. So if you look for anything written with the help of API platform, and probably maybe they showcase something on their site, then I would suspect that these might be some APIs which actually use Hypermedia and Hydra.
Yeah. Tomasz, do you have any good examples?
There's probably not much public, and I know of a bunch of teams actually answered. I typed while you were also discussing.
Okay.
So yeah, well, we build Hydra APIs for our clients, but it's not strictly public APIs either. And I know a bunch of other teams that do similar approaches, but it's quite often behind closed doors. Nothing, not like a big vendors that could boast. But Hydra aside, I mean, I've certainly met many people who build Hypermedia in general.
Right.
And then, well, to repeat what I typed also in the answer, well, the challenges are in fact to build those those reusable building blocks components so that they are customizable and actually will provide the right level of user experience, because an often accusation towards generic user interface is that it's plain ugly. So you need to be able to integrate with, speaking of web design, you need to be able to integrate design systems and easily extend to get the look and feel of your app. And obviously performance is also a factor that may be not in favor of REST APIs in general. That's why we have GraphQL, right? So that you don't have the chattiness of going back and forth multiple times to your API.
So it seems like it's certainly possible, but we're just not seeing so many use cases out there yet. But didn't Tomasz, you did present at least a sample application at one of the Nordic API summits, the wikibus.org, right?
Yes, it's
is that still available for people to explore?
It's still running. All the code is a bit of my personal playground, so it's not as good as I wanted to, and it's constantly as much as I have time, try to upgrade to the latest and greatest.
Right. And then for viewers wanting more information on this and potential use cases, there is someone in the community, Asbjørn Olsberg, talks about this quite a bit, different API change strategy and how to design a true REST state machine. I'd recommend checking out some of his articles. Some of that is on the Nordic APIs blog as well. And we'll do some digging for some Hydra in practice use cases to explore on the blog too. I'm curious as well. Perhaps, we've gone a little over time, but I still want to get some input on, just the amount of time it takes to build Hypermedia into APIs. Developers often scoff at it and saying, it's not really necessary to make RESTful APIs. So it just takes a lot of self-reflection, and things are referencing more. So it is another, it's another added burden for API designers. So when do you think this makes sense, and when do you think it's worth the extra effort? Maybe we'll start with Michał on this.
Yeah, I would say I think especially when you have mobile clients consuming APIs, because as I said, it's whenever you have a mobile app and you want to change anything on the side of the client, it's really hard. And well, it's not hard to release a new version, but it's really hard to get people to upgrade to the newest version, or it's easier to publish versions in the Google Store, when in the Apple Store you have to go through the process of they're checking, making some revisions of apps, and it can take, I think, like a week or even more to release new versions. I'm not sure how it works in the Huawei store or the Xiaomi or whatever it is. I think Huawei has their own, right? Yeah, but I would say in mobile, especially in mobile world, using Hypermedia can solve a lot of problems and help you really a lot. And I think that would quickly pay off to have Hypermedia clients, which can just react to changes which happen on the server, and just render accordingly on the client side.
Great. Yeah, Tomasz, any kind of lasting thoughts on the net benefits of Hypermedia clients?
Well, I totally agree with the mobile. There is this app called SkyCash in Poland, which is basically a payments app. And I'm pretty sure, I have no proof for it, so I'm pretty sure it's actually driven by something Hypermedia-like or Hypermedia, given that it just keeps adding new features. They all look similar in the user interface, but without really updating the app at all. They just push new services that you can purchase. And obviously another case is not really controlling the clients, so that if you do not control the client, you have no, I mean, it's also a potential trap, because if clients hard code against your API and you want it to be Hypermedia driven, then you can easily break. But I mean, it's at the client's it's a client's risk. But potentially, if you have many clients, maybe you have different platforms that even you control. With Hypermedia, you don't need to push the changes down the line. You only potentially change the API and only infrequently update the client code.
Okay. Well, it seems like we've covered a lot of ground. We've gone through all the Q&As here, I believe. Yeah, thank you to both of you for presenting and sharing your ideas and entertaining some wild ideas in the Hypermedia realm here today. Yeah, thanks so much. I'm just going to be signing off with a couple wrap-up slides, and then we'll call it a day. So yeah, some quick updates from Nordic APIs. First off, if you own and operate an API, time is running out to nominate it to the best public API competition of 2021. We do this every year. This is going to be the 4th time Nordic APIs has put on this competition. And we'll be keeping this nominations open throughout the end of this month, after which our judges will crown the next public API. If you would like to nominate yours to be considered, you can use the submission form located at that URL. Also, we love featuring new contributors from our community on the blog. We have a decent footprint for sharing new ideas. So if you love APIs and want to share your story, our blog is open. You can read our submission guidelines and pitch a topic at nordicapis.com/createwithus. We also operate a newsletter featuring bi-weekly updates from our writing team, who are covering many pressing areas in the API space. You can sign up on the website to always have a little bit of API knowledge in your email inbox. And until it's safe to hold our typical in-person summits, we'll be arranging these monthly webinars. So if you do have something interesting to share, feel free to submit a talk and I'll consider it as we're planning these upcoming live casts. And finally, as usual, thank you to our sponsor, Curity. You can learn about their OAuth server and identity-driven API security solutions at curity.io. So that's all for now. Thanks so much to our speakers and people who tuned in and asked us some great questions. We'll see you at our next event. All right, bye.